In this video, I'm going to do the first 4 problems of the acceleration homework, and you're going to need these equations for the rest of the problems that you're going to have to do. So let's start off with number 1. The formula for acceleration is a equals delta v over t. Solve this equation for the change in velocity delta v. And so if you remember the algebra with shapes video that I made, if I look at this equation, a equals delta v over t, delta t, a is like the blue circle, V is like the green diamond, and A is like the red square. Okay? And so if I'm going to solve for the green diamond, I'm going to solve for delta V. So let me first draw the whole equation. A equals delta V divided by delta T. And we're going to solve for the green delta V. Okay. Now to do this, I need the green delta V by itself. So I'm going to need to multiply by delta T. Because delta V is being divided by delta T, the opposite of division is multiplication. So I'm going to multiply by delta T. If I do it to one side, as we saw before, we have to do it to the other side. So I'm going to multiply by delta T on this side. When I do that, on this side over here, delta t divided by delta t is 1, so those cancel out, and you're left with your final equation, which is delta v equals a times delta t. Now you might ask, well, why not? Shouldn't it be delta t times a? Yeah, it can be, but we know the associative property of multiplication allows us to flip this. 3 times 4 equals 12. 4 times 3 equals 12. So a times delta t equals delta v, or delta t times a equals delta v. Either way, this is our final answer for number 1. Okay. On to number 2. If we look here, it says solve for delta t. So I need to solve for this right here. So just like the red square in the previous video. So let me write out the original equation again. A equals delta v divided by delta t. I have to solve for delta t, and so the first thing I need to do is get delta t in the numerator. So I'm going to multiply by delta t on both sides. When I do this, on the right side of the equation, the delta t's cancel. However, on the left side, I get delta t times a equals delta v. Okay, so when I do that, I need delta t by itself, so I'm going to have to divide by delta a. It's being multiplied by a right now, so I'm going to do the opposite, which is divide, and then I'm going to divide by a, blue a. Okay, do it to one side, I got to do it to the other side. Okay, and then a cancel on this side, so my final equation is delta t equals delta v divided by a, and that is my second derived equation. Okay, so remember, our base equation is a equals delta v over delta t. We derived delta v and we derived delta t. Now we're going to move on to a bit more involved manipulation of this equation, and that's solving for v sub f, which stands for final velocity. Remember, when we talk about this equation here, delta v equals a times delta t, a times delta t. We know that delta anything is change. So change is just final minus initial. And so as we see here, delta v equals v sub f divided by, or minus v sub I. V final minus v initial. And so delta v here, I'm going to expand to v final minus v initial. Okay. V initial. And that will equal, whoops, a times delta t. Okay. Now what I'm going to do here is I want VF by itself. And so what's being done to VF? It's being subtracted by VI. So to get rid of this VI that's subtracting from VF, I have to add. So I'm going to add V sub I, or initial velocity. Do it to one side, I got to do it to the other side. Add V sub I. Okay. And when you do that, VI cancels on both sides. And you can imagine that this is kind of its own quantity by itself. So our answer and final equation for V sub F, final velocity, would be equal to the quantity A times delta T, A times delta T, plus V sub I. Okay, initial velocity. So final velocity equals acceleration times change in time plus initial velocity, and that would be our final equation. All right. Okay, so the last equation we have to solve is problem number 4, and we're going to be solving for V sub I. V sub I. V sub I. Now, one thing you want to remember is that I'm actually going to take this previous equation, V sub F equals the quantity A times delta T plus V sub I, and I'm going to flip it around. And not only going to flip it around, but I'm going to make the V sub I come first. In other words, I'm going to go V sub I plus the quantity A times delta T, A times delta T equals V sub F. Okay? And so remember, I can flip any equation around, put the right side on the left side, left side on the right side. And because addition is associative, 3 plus 4 equals 7, 4 plus 3 equals 7, for example, I can do the same thing here. And so I'm going to start off with this equation, and I need to get V sub I by itself. Well, what's being done to V sub I? It's being added by the quantity A times delta T. So I'm going to subtract. What am I going to subtract? I'm going to subtract the thing I want to get rid of, A times delta T. So minus A acceleration times delta T. If I do it to one side, I got to do it to the other side. Subtract A times delta T. Acceleration, change in time, and do it to one side, I got to do it to the other, and these will cancel right there. That'll cancel, and those will cancel as well. Okay, and so I'm left with my final equation. V sub I equals the V sub F, so final velocity. So your initial velocity equals your final velocity minus the quantity A times delta T. Acceleration times change in time. And so when we look at this, this is our final equation that we have to solve on this worksheet. We have solved for, first of all, given acceleration equals change in velocity over change in time, we solve for change in velocity, we solve for the change in time, we solve for final velocity, and we solve for initial velocity. And we're going to need all 4 of these equations when we do the rest of the worksheet. Okay?